Now we're going to look at modeling periodic behavior using sinusoidal functions. So example 4 says the average monthly temperature for a small town in Oregon is temperatures for a small town in Oregon given by the table below. Find a sinusoidal function of the form y equals a sine b times t minus c plus d that fits the data to the nearest tenth. And then sketch the graph. So let's look at what we have here. And I can't really fit it all on one screen. I got to kind of scroll it. Let me see if I can. I could right there. I got it all on one screen. If we look at the low temperature and we look at the high temperature, 69. So that gives us helps us get our amplitude. So the amplitude is going to be 42.5. So amplitude, I'm going to go to blue, equals 69 minus 42.5 divided by 2, because that's the whole range. And there'll be a cinder line, and so we would need half of it above, half of it below. And so for this, we get 13.25. That's our amplitude. Now for our B, the period is 12 months. So 2 pi over B is 12. So 2 pi is 12b divided by 12. B must be pi over 6. So we're starting to build up all the components we need. Now let's look at finding D, our vertical shift. So if we look at our highest value, so vertical shift. So we'll do the highest value plus value, lowest value, and then we can divide by 2 to show us where that center line is going to be. So that's 69 plus 42.5 divided by 2 is 55.8. So right now, if we put it together, we have y equals 13.25 times sine of pi over 6 minus, or pi over 6 times x minus c plus 55.8. So now we have to find the c. So if we put in one of the values, for example, let's say at month 1, month 1 corresponds to 42.5. So 42.5 equals 13 point, maybe I should just go to one decimal place. 13.3, let me just do that, one decimal place. Make it easier with the other numbers. Times sine of pi over 6 times 1 minus c plus 55.8. And I can subtract 55.8 from both sides. And I have negative 13.3 equals the 13.3 sine of pi over 6 minus c. So that's, if I divide by 13.3, that means negative 1 equals sine of pi over 6 minus c. Okay, so sine of what makes negative 1? And it would be 3 pi over 2 or negative pi over 2. So if we said it's negative pi over 2, then we have this pi over 6 minus c equals negative pi over 2. So c would be pi over 6 plus pi over 2, where c equals 2 pi over 3. So let's write it over here. Y equals 13.3 sine of pi over 6 times x minus 2 pi over 3 plus 55.8. There you go. Let's go on to the next one. The hour hand of a large clock on the wall in Union Station measures 24 inches in length. At noon, the tip of the hour hand is 30 inches from the ceiling. At 3 p.m., the tip is 54 inches from the ceiling. And at 6 p.m., it's 78 inches. At 9 p.m., it's 54 inches again. And at midnight, it's going to be back up to 30 inches from the ceiling. So let x equal the distance from the tip. Boy, my other phone's going off a lot. Sorry about that. Let y equal the distance from the tip of the hour hand to the ceiling x hours after noon. Find the equation that models the motion of the clock and sketch the graph. Okay, so we have noon. It's 30 inches. So that'd be 0, 30. At 3, it's 54 inches. So we have 3, 54. At 6, it's 78 inches. So we have 6, 78. At 9, it's 54 inches again. So we're at 9, 54. And at midnight, it is 30 inches, so we're at 12, 30. So our amplitude is going to be, the absolute value is going to be that biggest number, 78, minus 30 over 2. That's going to give us 24. So, and every 12 hours, this is the process, this is the period it's going through. So we're looking at 2 pi over b equals 12. So 2 pi equals 12b divided by 12. B equals pi over 6. Let's look at the vertical shift. That's going to be 78 plus 30 divided by 2, which is 54. And this gives us the formula y equals negative 24 cosine, y negative because it starts out with a smaller amount, cosine of pi over 6 x plus 54. There's no phase shift to worry about. So if we were to graph this, we'd start at 30. It's going to go up. Our center line is at 54. And our peak is at 78. So this would, and I'll go ahead and do 3 o'clock, 6 o'clock, 9 o'clock, 12 midnight. And we're starting there. At 3 o'clock, we're at 54. 6 o'clock, we're at 78. Then we're at 54. And then we're at 12, or sorry, at 30. So we get this kind of a curve. And there's our graph. Okay, let's go on to example 6. The height of the tide in a small beach town is measured along the seawall. Water levels oscillate between 7 feet at low tide and 15 feet at high tide. On a particular day, low tide occurs at 6 a.m., high tide at noon. Approximately every 12 hours, the cycle repeats. Okay, so I think we're starting to see our B. It seems like 12 as a cycle. I'll just go with that. B is going to be pi over 6 because 2 pi over B equals 12. And Then solve for B. Okay, how about our amplitude? It's going to be 15 minus 7 divided by 2. So we're going to get 4. And then our D, it's going to be 15 plus 8. Should that be 7? 7 feet and 15. So I'm going to say 15 plus 7. Divided by 2. That's going to be 11. And so we have y equals 4 is the amplitude, cosine of pi over 6 times time plus 11. And we basically get a graph that looks like, here's the 15 mark. It's going to go down to the 7 mark. We have our center line here at 11. And it's going to come down like that. Okay, our last problem. I want to keep this under 15 minutes if I can. We have, it says the average person's blood pressure is modeled by function f of t equals 20 sine of 160 pi t plus 100, where f of t represents the blood pressure time t, measured in minutes. Interpret the function in terms of the period and frequency, sketch a graph, and find the blood pressure reading. So we have our amplitude, 2 pi over b is going to be equal to 2 pi over 160. 160 pi. So it's going to be 1 over 80. That's a period. I have to change all these values down here. So in a blood pressure function, our frequency is going to be the number of heartbeats per minute, and it's a reciprocal of the period. So the frequency is 80, if that matters. So on the blood pressure graph, looking at this function, 20, and the most sine could be as 1. 20 times 1 is 20, plus 100 is 120. So we're talking about a blood pressure of 120 over 80. And so we'd start at, since it's sine, I'm going to call this the center line, call this the 120, call this the 80, and it's going to start here. And then one complete cycle, I mean, that's going to be 1 over 80. It's going to be hard to really show that. But for the period. You end up with getting a curve like that. So these are kind of irrelevant. Okay, so 120 over 80 is, by the way, considered normal. Top number is the maximum or systolic reading, which measures the pressure in the arteries when the heart contracts. The bottom number is the minimum or diastolic reading, which measures the pressure in the arteries as the heart relaxes between beats. Thus, normal blood pressure can be modeled in a periodic function with a max of 120 and a minimum of 80. Okay, that's it.